ANOVA hypothesis test, mark all that apply. Sample means are all positive. Yes. Data in
Yes.
each are normally distributed. Yes. Variances are equal in each group. That one I'm not positive about. I don't think it's the last one. So just the first two. What do you guys think?
So I think it's the last two. Yeah, because
really?
the sample means they don't have to be positive because they're going to be squared or cubed, I can't remember, in the formula. And so it will automatically make them positive.
And the item 3.2, in the textbook, we find these answers.
Correct.
Okay.
There are two requirements of ANOVA that must be checked. The data are normally distributed in each group,
Yep.
B, and C, the variances are equal for each group.
Correct.
Yes.
Yeah.
So now the F scores, this is where I think that you were meaning the F scores will always be positive.
Thinking of that.
Yeah, yeah.
So
Yeah.
sample
Okay.
mean, okay, yeah.
Yep, so it's just the second two that we'll check.
Yep.
Okay. To check if each group is normally distributed, do the following. Construct a scatter plot of the data in each group. Construct a histogram of all the data. Construct a QQ plot for each group. And I put construct a QQ plot for each group.
Yes, me too.
Okay.
We assume the variance in each group is the same if the following happens. Sample variance for each group is smaller than the sample mean. The smallest variance. The largest sample mean is less than 2 times the smallest sample mean each group has. Sample size. It's the 4 times the smallest variance, right?
Yes, for me, the second option.
Yep, that's what I put. The largest variance is less than 4 times the smallest variance.
Yes, the second option. No?
Yep.
Okay, me too.
Okay. And ANOVA, sorry, my dog is just going to be a pain tonight because trick-or-treaters, stop. Trick-or-treaters freak out. Charlie, stop. So, an ANOVA hypothesis test is equivalent to conducting independent 2-sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs of 1 to 2, 1 and 3, 2 and 3. How many pairs are there when there are 4 samples? I put 6.
1, 3, 1, 4. 6, no?
Yeah.
Yeah, is that right? 6?
6, yes.
Okay. Oh, good, because that took me a minute. That probably took me way more than it should have.
Okay. The data in soccer shoes was selected to help determine how the design of a soccer shoe affects the accuracy of a kick. There are 5 types of shoes labeled A, B, C, D, E, and also just wearing socks for a total of 6 groups. Each row represents a kick from 10 meters away from a target that was 115 centimeters up from the ground. The column accurate distance in centimeters from where the ball impacted the target to the center of the target. So smaller numbers are more accurate. Questions. What is the minimum?
Let me open the
variance groups. Okay, let me find. Sorry.
Just a minute. I'm filling the spreadsheet. Just a minute.
I wish they would make it so you could just copy and paste it from one to the other instead of putting it in one single line.
No, we need to divide the no A, B, C, D,
Yeah.
E. No,
Yep.
variable 1 A,
Yep.
variable 2 B, like that. No,
Yep.
and just a minute for D. And E. So I have socks.
Mm-hmm.
Variance. What's the minimum variance for the 6 groups? Variable 3?
That's what I put. 27.208.
Yes, me too. 208.
Okay, can you tell me how you got that?
Yep. Let me just show you. Let me just show it to you really fast. Okay, so you get your variances right here,
Mm-hmm.
and number 3 is 27.208, and that's all the data from this. So this is their individual means and their individual standard deviations and their individual variances. And all of this down here is when you've combined them.
Okay.
Does that make sense? I know that was really a yucky way of explaining things.
No, I think it does. Wait.
And the instructor said it does not matter what order you put your variables in.
It doesn't.
Nope, it doesn't matter.
Okay. Let me just check something. And so when he asks for the minimum, he doesn't want the number, he wants the variable number.
Yeah, I think it wants the because it asks for, let me find it. It asks for it asks for the variance for what is the smallest variance for the 6 groups? And it says round to 3 decimals, so that's what kind of threw me off. It didn't want the variance, it didn't want the group number, it wanted the variance.
Okay. Got it. So we would just put variable 3. Is that what you're saying?
Yeah. So I put 27.208.
Yes, me too.
Answer.
Oh, okay. That's why I was confused. I was like, wait.
Oh,
so
sorry. Well, I thought that's what I thought you were asking the first time, if we were supposed to put variance 3, and I was like, no,
Okay.
sorry. Oh my goodness.
My bad.
No, that's okay. So number 9, what is the maximum largest variance for the 6 groups? And I put 53.158.
Yes, that's correct.
Okay.
Okay. Question 10. The test for equal variances is satisfied for these data.
Yes, true.
True.
Because
I put true as well because it's not 4 times larger than the smallest.
Yeah.
Yes.
And so if it is, then it would be false, right?
Then it would be false. Yep. Okay. And this is where what I was doing before we started recording. Construct a QQ plot for each of the 6 samples. Each of the sample means are approximately normal based on what you see in the QQ plot. So I already did that. Took a minute, and it's true.
Okay.
You.
You're welcome. I was just like, oh, that's going to take forever.
I believe in your words.
Okay.
Okay. Perform an ANOVA test in SPSS and observe what the p-value is for a point, or is, observe that the p-value is 0.081, then remove the SOX data and perform the test again. What is the p-value when we remove the SOX data?
So I'm assuming that it's okay to do it in Excel because we don't use that.
Yeah, we don't use SPSS, right?
Yeah. So we're supposed to remove the SOX data?
0.3.
Just like in the spreadsheet that he gave us, or?
Yeah.
Okay.
And I have 0.309 for the.
0.309?
Yeah, is that what you guys?
Yes, that's what I have.
Okay. Oh, sure. Oh. Okay. What is the test statistics for an ANOVA hypothesis test? The test statistics for an ANOVA hypothesis test is an F statistic. Is the p-value area to the right or to the left of the F statistic? And it is to the right. It is right skewed.
Right skewed.
Researchers at Consumer Reports analyzed 3 types of hot dogs, namely beef, poultry, and meat, mostly pork and beef, but up to 15% poultry meat. For each of the 54 hot dogs analyzed, they recorded the type, the calories, and the sodium level. Their data is available in a file. Use this data file to answer many questions. Question 14, let's examine the calories first. Construct QQ plots of the calories for each of the 3 types of hot dogs. Compare the variances to determine if the assumptions used ANOVA have been met.
Variable 1. Meat.
I didn't do this one. Let's see the calories first.
Meat.
Ugh.
Poultry.
So the QQ. Oh my gosh, this is pretty.
So we're just looking at the calories first, right?
Yeah. So I just did the calories for beef, and it looks normal.
Okay.
I've got so many spreadsheets open, I can't even keep them all straight. So I would say that they're all. Let's see, what was the question again? The assumptions have been met. It's safe to assume that each group comes from a normally distributed population from the QQ plot. We can also assume that the variances are equal. I would say it's the first one because I thought I thought the QQ plot showed that they'd all been met.
Yes, because the other alternative is the assumptions have not been met.
Yeah.
Yeah.
I think the first is correct.
Okay.
What about you?
Yep, I agree. Run an ANOVA test to determine if the mean number of calories is the same for all three types of hot dogs. You should find that the degrees of freedom are 2 and 51. That F equals 16.074 and the P equals 0.00 with a level significance equal to 0.05. What conclusion do you draw? Well, if we have sufficient evidence to claim that all three hot dog types have the same mean calories. Okay, let me just run it. It would just be easier to see it. Okay. Beef for calories.
Maybe the last one. I don't know. I think we have sufficient evidence to claim that at least one of the hot dog types has a different mean number of calories than another type. Probably. Let me check on the textbook. Yes. Yes, because the H0, all the means are equal. So we are not accepting the hypothesis 0 as correct. So at least one of the means differs. So the last alternative, we have sufficient evidence to claim that at least one of the dog types has a different mean number of calories than another type, because the p-value is smaller than the level of significance.
Actually, yeah, I agree with that. Because
I agree. Yep, I agree with that too. Let's see, because it has a mean number. Oh yeah, because variable 1 and variable 2 both have means of 156 and 158, and variable 3 only has 118.
Yeah.
Yes.
So I agree. Okay, now let's examine the sodium. Oh, great. Let's examine the sodium levels. Construct a QQ plot of the sodium level for each of the three types of hot dogs. You should see that the QQ plot for poultry suggests a possible problem with the normality assumption. The smallest variance is 7,180.75, and the largest is really big. Have the assumptions been met to use the ANOVA? No. Well,
no.
It's got to be 4 times. So what's 4 times 7,180?
I'll check it. It's 28,728.
So then, let's see, 1, 2, 3. So it has been met because it's not 4 times.
Yeah, this
right?
is only 10,000.
Yeah.
So it's not 4 times larger.
Yep.
Yes. So the assumptions have been met, but let's see.
Well, that's only the first option, right?
Yeah.
There is only one.
Yeah.
No?
Yeah.
Okay, despite the possible problem with the QQ plot for poultry, you decide to use ANOVA to determine if the mean sodium levels are the same for all 3 groups. What is the p-value for this test?
Okay.
So for sodium, now.
Sodium into beef.
Sodium beef.
Sodium.
Meat.
So I got 0.179.
Just a minute, please. Poultry. So p-value 1.0. 0.179.
0.179. That's what I got. So we got 0.7179, right? 0.179. I just cleared my page. Oh, I hate having so many windows open.
Using.
It is so confusing. Okay. All right. What conclusions can you draw about the mean sodium level of the 3 types of hot dogs? Use a significance of alpha 0.05 and the p-value point. So we fail to reject the null because the p-value is 0.179. So let's see what the answers. We do not have sufficient evidence to reject the claim that all 3 hot dog types have the same mean sodium level.
Yes, for me, this is the correct answer.
Yep.
You agree? Okay. Sorry. Okay. Charlie, come here. Oh my gosh. So I'm saving all my responses.
Did you put the first on the last question?
I put the second one, that we do not have sufficient evidence to reject the claim that all 3 hot dogs types have the same mean sodium level.
Yes.
Because our p-value is bigger than our alpha.
But
right?
Yes.
Mm-hmm.
Okay.
Good job, guys.
Oh, you already submitted it? Look at you go. I was too busy yelling at my dog.
Mm-hmm.
Thank you for putting up with her.
No problem.
Hey, look at that. Okay. All right. You guys are awesome. And I will post this right now. And I'll see you Thursday.
Awesome.
Okay.
Thanks.
Thank you very much.
Bye, guys.
Have a good night.
Bye.
You too.